Okay. So last time we dealt with what is standard form. We talked about converting from vertex form to standard form. That wasn't a big deal. You FOIL and distribute. What we need to look at now is going from standard form to vertex form, which is a little bit more involved. And there are two different methods we're going to look at, and you will need to know both of these methods. The first one is called working backwards, which is a little bit of cheating, sort of. And then the second way involves actually doing some factoring that will convert, will give us the single p squared and all that stuff. The working backwards method. Here's how this is going to work. We're going to take a look at that parabola y equals x squared plus 2x plus 5. I want to convert to vertex form by this working backwards method. First of all, I know if this is going to be in vertex form, what the answer should look like. The answer is y equals, well, can someone tell me what vertex form looks like? A plus k. Good. And I really hope you all just knew that for that quiz. So I know my answer. My answer has to look like y equals a times x minus h squared plus k. What do h and k stand for? The vertex. Do you know how to find the vertex? Like how? Okay. Step number 2, we are going to find h and k by finding the vertex. That's the whole negative b over 2a, plug in, and all that stuff. So do that right now. From standard form, take a moment, calculate your vertex. Do your negative b over 2a to get the x value, plug it in to get the y value. Negative 1, 4, I believe. Negative 1, that's my h. 4, that's my k. So my parabola should be y equals a times x plus 1 squared plus 4. And I'm almost there. I just have to find the a value. Say that one more time. What do you mean? Yep. But fill in what? There's a really easy way to find the a value. There's a really easy way to find the a value. Easier than that. Natalie. I think that's what Philip was about to say. There's an easier way. Preston. There's a reason we're calling the a value in standard form the same as the a value in vertex form. It is the exact same thing. The a value, so step number 3 is going to be the a value is the same in vertex form and standard form. So in the original problem, what was the a value? 1. In the new problem, the vertex form, what's the a value going to have to be? 1. That's as difficult as the a value is. That's the easy part. Your answer is y equals 1, no, you don't have to say that, times x plus 1 squared plus 4. That's it. We know what the answer looks like, so we're going to find the vertex, that's h and k. To find the a, all you have to do is take it from standard form. Does this make some sense? Do letter A on your own. You know what the answer is going to be. It's y equals a times x minus h squared plus k. Find the h and the k. That'll take a little bit of work. Find the a, that should not take any work. Can we get 2 comma 11 for the vertex? Kayla, do you have the final answer?
Y equals negative 2, x minus 2 squared plus 11.
Good, and my only question is, where did you get that negative 2 from?
The a in the vertex.
Same thing that it was over there. Does this make some sense? We're calling this method the working backwards method. I kind of said it was sort of cheating because algebra should really mean we should be able to like do some things to this side and that side, like actually convert this thing to vertex form rather than I just know what the answer is, I'm going to fill in all the details. The second method we're going to look at now will actually be all that algebra to convert stuff, and we do need to be able to work with both of these things. Katie? Yes, because this other method is going to be useful for more than just this one particular type of problem. It's going to be useful for some other things. So we need to see how we can actually do some factoring to get our vertex form. Question, Nathan?
So the other quiz would be in a section where we have to do one part.
Yep, I'm going to say I'd like you to do this by the working backwards method and this by the completing the square. Same in tonight's homework, and make sure in the homework tonight you are reading the directions and using the appropriate method. If you use one method on everything, I won't be able to give you full credit for the homework because you didn't do what I needed for certain parts. The second method is called completing the square. That name should sound really, really familiar because we did that with our quadratic equations. This is a little bit different, but in some ways a little bit easier than the completing the square we did with the quadratic equations. First of all, we started our completing the square problems with the quadratic equations by getting the x's on one side, constant on the other. Well, I can do that, but there's something extra thrown in this problem here. What extra little thing did we not have in the last chapter, Preston? The y. Well, that's okay. Step number 1 is going to be get the x terms on one side and the constant in y on the other side. By the way, this example is exactly the same one we just did by the working backwards method. I want to show that we can get the same answer using this new method. Get the x terms on one side and the constant in y on the other side. That's easy algebra. Minus 5, minus 5. We're going to get y minus 5 equals x squared plus 2x. Now, there's something nice about this problem. What number do you have before the x squared? 1. Remember that I told you completing the square only works if there's a 1 before the x squared. Sometimes there won't be a 1. However, we're not going to divide because that's going to give you like messy, horrible things. Step number 2, which is not going to apply to this problem nor the next few, just write it down, I'll explain later, is going to be factor out the a value on the side with the x's. Don't worry about that for right now, but I do want it in your notes. We'll see how to use that in a little bit. Factor out the a value on the side with the x's. There is no a value in this problem, so that doesn't matter. Step number 3 is my actual completing the square step. I need to complete this side to make it a perfect square trinomial. Well, in the last chapter, what would I have added to this side? So like what? 1. I'm going to do half my middle number squared and add that to this side. Half of 2 is 1. Square it, gives you 1. I'm going to add 1 over there. I'm going to add half the middle term squared to the side with the x's. What other thing am I missing that I really can't just leave like this? And add it to the other side as well. I'm actually going to change my language a little bit, but it's the same idea. I'm going to say balance it out on the other side. There's a reason I'm changing this. We'll see later. But add 1 to the right, so balance it out by adding 1 to the left. Up a little bit. Step number 4, we're going to go factor. Same way we did with our completing the square from the last chapter. X squared plus 2x plus 1. Raise your hand and tell me how that gets factored into a single piece in parentheses squared. X plus 1 squared. Remember, the number's always coming from half our middle term before we do the square. Does this almost look like a parabola in vertex form to you? Should I now do my plus or minus square root? No, then it won't look like a parabola anymore. There's only one easy last step. Josh? Yeah, solve for y. And I'm going to be picky on the work here. I don't want to see that. Josh, why don't I want to see that? Show it on both sides. Some of you have not been doing that, and you will lose some points on this quiz that we have on this stuff if I don't see it on both sides. But your parabola is going to look like y equals x plus 1 squared plus 4. It's a lot of what we did in the last chapter, just we're stopping before we do the plus or minus square root, because now I have my parabola. By the way, could you look at this and quickly tell me what the vertex is? -1 comma 4. Is there any way you could look at something in this problem and tell me the y-intercept very quickly? Eli? Give me coordinates. 0 comma 5. From this? No. From the original. The standard form is good for the y-intercept, but the vertex form is good to tell us the vertex very quickly. I want to do the next 2 problems together, and then I'll give you 1 or 2 to try on your own before we move on. Letter A. Oh, and when we are done here, we are asked to find the vertex and y-intercept, so we'll take care of that. First, x is on one side, y and the constant on the other. So with that in mind, Jock, what would I do first in letter A? We're on page 16. X is on one side, y and the constant on the other. We need to subtract 19 from both sides. X is on one side, constant with the y on the other. Y minus 19 equals x squared minus 8x. We now get to our completing the square step. Evan, how are we going to figure out what to add? Good. We should be doing -4 squared, which is what, Evan? Good. And I need to see you adding 16 to the right and 16 to the left. I now have that shortcut factoring step to deal with. So we're going to get, Maria, what's that right side going to factor into? X minus 4. X and then half the middle number before we do our squaring. So x minus 4 squared. Easy last step. Plus 3. Plus 3. Y equals x minus 4 squared plus 3 is our parabola in vertex form. What's the vertex? 4, 3. What's the y-intercept? 0, 19. Y-intercept, remember, comes from the C from the standard form. Vertex comes from the H and K in our vertex form. I want to do B together, and then I'll give you one to try on your own. Sam, first step in letter B. Subtract 4 minus 4 minus 4. Y minus 4 equals x squared minus 3x. Half the middle number squared. I need to do negative 3 over 2. I need to square that. On the test, I saw some of you doing it like twice, doing negative 3 over 2 and then doing half of that. No. The middle number was negative 3. Half of that is negative 3 halves. That's what I'm going to square. Don't do another 1/2 times that thing. If we're doing that, Heather, what am I going to add to both sides? Sure. I'm going to add 9/4 on the right. I'm going to add 9/4 on the left. Well, let's take care of the factoring. I know the right looks a little messy with the fraction, but the factoring should be the same formula we've been using with everything else. Olivia, can you tell me what the factoring is going to be? There's a shortcut to figure out what that number is going to be. Want some help? Robbie, can you tell me what the factoring is going to be? Letter B. X minus 3 halves squared. X and then half the middle number before we do our squaring. Question, Katie?
No.
On the other side, I need to do some common denominator work so I can add those. So I'm going to say 9/4 plus y minus 16/4. That gives me negative 7/4 plus y equals x minus 3 halves squared. I'm going to go and add 7/4 to both sides.
Can we do y minus 7?
Absolutely, you can. And I'm going to get y equals x minus 3 halves squared plus 7/4. Very quickly, write down the vertex and the y-intercept for that problem. No. Vertex should have been 3 halves, comma 7/4, with a y-intercept of 0, 4. On the little piece of paper I gave you, flip it over to the blank side. And I would like you to do y equals x squared. Should I be nice or should I not be nice?
Not nice. Not nice.
You're going to be on Santa's bad list.
Not nice.
What am I talking about by being nice?
Bad.
If I want it to be nice, what should the middle number be?
Jewish? Even
Yes, but that has nothing to do with anything. What should the middle number have to be? Even. If it was odd, you get fractions. I don't really have the time to make it complicated. Oh my gosh, we're not dealing with that right now. You are going to go convert this to vertex form by completing the square, because we still have to look at C and D, which are definitely tougher.
What's the Jewish version
Don't.
of Santa?
There is no version. There's the completing the square fairy. Go do that. Oh my gosh. Oh my gosh. Go complete the square. As usual, make sure you are showing all the algebra but you're moving from side to side. When you're adding something, it has to get added to both sides at the same time, all that stuff. That's a 13. It's not an 8, it's 13. Oh my gosh. I'm doing it with a 13. Natalie, what are you going to add to both sides to complete the square? 9. Half your middle number is negative 3. Might as well write that down. Half of negative 6 is negative 3. Squared gives you 9, so I'm going to add a 9 to the right, balance it out on the left with a 9 over there. I'm going to combine like terms. Y minus 4 equals. Judah, how did you factor the right? X minus 3. X and then half the middle number before we square things. That's it with the hard stuff here. Now we're going to add 4 to both sides. Y equals x minus 3 squared plus 4. Vertex is 3, 4. Y-intercept 0, 13. Nod your head if you're with me, more or less. Okay, it's tougher when there's an A value out front. That's what we need to look at with C and D. The first step in C is very, very easy. Subtract 99. Minus 99, minus 99, that is nothing new. Y minus 99 equals 2x squared minus 28x. I am not going to do what I did with my equations and divide everything by 2, because if I did that, I'd have to divide the y by 2 and get y over 2. That's a mess. And 99 over 2, I'm going to get fractions. There's a better way, which is what I wrote in the directions on the previous page. It said rather than divide, it said to factor out the a value. So, what I mean by that is we're going to get y minus 99 equals, I'm going to factor out a 2 on that side. Not the GCF, not 2x, just the number 2. Let me keep going, you'll see why in a moment. I'm going to factor out the 2, I'm going to get x squared, and what else? Minus 14x. Okay. Now, this is very important, so I need you to pay close attention to what I'm about to do. No, I haven't really done anything yet. Right? Won't I have to complete the square? This means I'm going to have to add something inside the parentheses. So leave a little space afterwards. We're going to figure out some number to add inside the parentheses. Well, to figure out that number, same as always. Half the middle number squared. Like always, half the middle number squared is what I add. Absolutely like always. What's half the middle number? No. Negative 7. Negative 14 over 2 is negative 7. Squared gives you what? 49. Right, like always. Here's where it gets weird. I am not going to add 49 to the other side. Listen very carefully. This is why you want to say something?
Oh, I know what you do.
What do you want to say, Jack?
So you multiply 49 times 2.
Here's the idea, exactly right. My directions to you said add half the middle term squared to one side and balance it out. I need you listening. The directions said balance it out on the other side. When I added 49 here, I didn't actually change that side by 49. I actually changed the right side by 2 times 49. Therefore, on the other side, I'm going to add in 98 because we actually changed the right side by 2 times 49. Do you see that? Adding in 49 actually really changes it by, well, the 2 times 49. That's the new, slightly weird part. The rest is normal. I'm going to get y, oh, this is really nice, minus 1 equals 2 times, well, factor that thing. Eli? X minus 7, well, almost, squared, plus 1, y equals 2 times x minus 7 squared, plus 1. The reason I only factored out a 2 rather than a 2x is because if I factored out a 2x, I wouldn't be left with something quadratic inside. I need to only factor out a 2, so I have an x squared term, and an x term, and a constant. Vertex here, 7, 1. Y-intercept, 0, 99. I want to do 4 together. And then I'll give you one more to try on your own, and we'll be good for it. In letter D, first step is easy. Philip, what's the first step in letter D? Track 7. That is no different than anything else we've been doing here. Y minus 7 equals negative 3x squared minus 12x. Okay, so now we have our new step. Shreya, what are we going to do next? Good. Just negative 3, not negative 3x, just negative 3. Y minus 7 equals negative 3 times x squared plus or minus? Plus what?
4 y
4 x. And I'm going to rewrite this thing with a little bit of space left so I can add some other pieces into it.
Would it be minus 12? Would it be minus 12? Or
You're a step ahead of me. Hold on. What are we going to add inside the parentheses? 4. Half the middle number is 2. Squared is 4. So Katie is saying, should it be minus 12 on the other side? Sure, because it's going to be negative 3 times 4. We're going to balance this out with a minus 12 because of negative 3 times 4, which is negative 12. You can finish this. And when you're done, raise your hand if you don't have more room on that little half sheet of paper that I gave you a moment ago. That's fine. So this is y minus 19 equals negative 3 times x plus 2 squared plus 19 plus 19. Y equals negative 3 times x plus 2 squared plus 19. I'm going to skip vertex and y-intercept just so we can get one more problem in.
is it negative 2 minus?
Negative 2, no, negative 2 comma positive 19. Okay, we don't need the comments on everything, Nathan. I would like you to try one more on your own. I would like you to try on that little half sheet. Y equals 8x squared minus 32x plus 17. I'd like you to convert that to vertex form. In the homework, make sure you read the directions carefully. If it says use the working backwards method, I need you to use that one. Y equals 8 times x minus 8 squared plus k, find the h and k and go. If it says completing the square, I need to see that method. So make sure you're using the appropriate method. This is completing the square. And definitely go back and use your notes when you're doing the homework tonight. Also, if you're bringing stuff for the food drive, please start bringing those things in. The food has to be in by Thursday, which actually doesn't give us a lot of time to do this. Thought I had one more minute. So I'm adding 4 inside my parentheses. And I'm adding 32 on the other side. I'm getting y plus 15 equals 8 times x minus 2 squared. Minus 15 minus 15, y equals 8. X minus 2 squared minus 15. Should be how this ends.